Hi, I'm Markus Florian, and today I'm going to show you our all-new multi-sensor device and how it can measure all the important data needed in a building automation environment. So this device integrates multiple functions, so it can, for example, measure temperature, humidity, and illumination level. Additionally, it also integrates a read contact, which is monitored in order to monitor if there is something open or closed, for example, windows or doors. And there is also a 3-axis acceleration sensor integrated, which gives you even more capabilities for the building automation environment. The uniqueness of this device is it's based on energy harvesting principle. So it takes ambient light in order to power the sensors and also stores the energy generated by ambient light in an internal energy storage so it can continuously transmit data also during night. There's another particular thing about this device. You may all know, of course, our PTM switch module, which is used by multiple switch manufacturers around the world. So we will realize that this multi-sensor can also be shipped in a version which is 100% mechanically compatible to the PTM form factor, and so it easily integrates into existing switch designs today already on the market. From a protocol perspective, of course, we will support this with the Ocean protocol in the sub-gigahertz range. So there will be a version 868 megahertz for Europe. There's also a version 902 for US and Canada, but there will be a third version, also 928 for Japan. Besides sub-gigahertz, we're also offering versions for the 2.4 gigahertz space, and they're specifically also for Bluetooth low energy and also easily being integrated in those environments. Now I'm going to show you how this device can be integrated into a professional building application environment or also to visualize data via an Android app, which we can also deliver to you. So I'm going to start the app, and then immediately it reports me, it visualizes the data generated by the sensor. And I can also show you that when changing the value, that of course this is being also reported immediately to this app. So for example, if I use a magnet to activate the read contact, I can immediately see that the window contact or the read contact is open or closed. And this is being shown here in this app. The same is also done if I, for example, cover the sensor with my palm. And then, of course, the value of the illumination sensor will be reduced immediately. And then when I take back my palm and give it a couple of seconds, then, of course, again, the value of the illumination sensor goes up. And the same I can do, of course, also with temperature humidity. So I've taken here a pot of hot water. And if I take the sensor next to the heat here of the hot water, then after giving him a couple of seconds to read the data, the humidity rises. And the same is the case also for the temperature value. And so here, this is some example of how you can visualize the data generated by the sensor. So this is here another example how we can visualize the data generated by our multi-sensor. So in this context, we have created here some kind of dashboard, which can be part of your professional building automation system. And it collects and visualizes all the data generated in the building. And of course, our multi-sensor is part of that data generation. Let's maybe start with one example. There is a read contact inside, of course, which allows me to monitor if a window or door is open and closed. At that moment, of course, the window, in this case, is open, and also the dashboard reports to me that the window is open. This information can, for example, be used for monitoring and controlling the heating system in my room. So, of course, in this moment, I would maybe turn off the heating control. In the moment I close the window, and I can simulate this by closing the lid here on the side, which contains a magnet, which interacts, in this case, to the read contact, and immediately my dashboard is reporting that the read contact is closed, and of course the heating system could eventually turn on. And this is being reversed in the moment I open here the lid again. A similar situation can happen if I read out the illumination level. At the moment I have light here in the room, it reports to me that there's about 520 lux. But of course this information can be used when, for example, light conditions are changing. Maybe the light level is going down. So of course this could be the trigger for updating and turning on my light system. So I can simulate this by closing the lid here. And in this moment, of course, the light level is being reduced and the information is also updated on my dashboard. So at the moment, since the lid is closed, I have only 26 lux and my light can eventually turn on. And of course also this can be reversed by opening the lid again, and the information will be updated accordingly the moment the light sensor gets again the full light. And here we are again at 510 lux approximately. And here, last but not least, I can also update this information by using the 3D acceleration sensor. I have here specified a certain threshold level, and the moment I turn my sensor here, then I exceed a certain threshold. So it means, for example, that an object in the office environment has been moved, and here the threshold signal gets into yellow or red. And of course, this is another trigger for doing further analysis in the context of monitoring the use in a certain office equipment. So this is again a nice summary how my multisensor can be implemented. Thank you for watching. For any questions, just let us know.